Hi, we will now talk about fractional exponents. What happens when you have a fraction in your exponents? So, in an example, it could be, say, 8 to the power of half, maybe 1/3. And then some people will say that, oh, this equals to 8 times 1/3 will be 8 over 3. Let's find out. So, let's look at this example. We know that, say, 9 is equals to 3 times 3, and it equals to 3 squared. So just for you to recall, what is the inverse operation of a square? If you remember what it is, we know that the inverse operation of a square will be a square root. So if you take the square root of 9, you should get 3, okay? And this is only the positive 3. We're taking the principal square root. So if you look at the number 9, it's equals to 9 to the half power times 9 to the half power. If we power of half, if we apply the product of powers property, we know that we can just add these two powers to give you 9. All right, so and from this case we also know that since 9 to the power of half times 9 to the power of half equals to 9, and also square root of 9 times square root of 9 equals to 9, right? Because these two numbers are, this is 3 and this is 3, they give you 9. So from this example here, you could see that 9 square root of 9 is actually equals to 9 to the power of half is equals to square root of 9. So this is what it means by fractional exponents. Another example that I will show you is, let's see, if we have 8 is equals to 2 times 2 times 2, and I can, so it's equals to 2 cubed, and the cube root of 8 would equal to 2. So 8 is equals to, 8 to the power 1/3 times 8 to the power 1/3 times 8 to the power 1/3. We know that if you apply the product of powers property, will be 1/3 plus 1/3 plus 1/3, and that should give you 8 to the power 1. Since 8 to the power 1/3 times 8 to the power 1/3 times 8 to the power equals to 8, and we also know that cube root of 8 times cube root of 8 times cube root of 8 gives you 8. This would, I hope that you can see some connection here. It shows that these three numbers should equals to these three numbers. Therefore, 8 to the power of 1/3 should give you cube root of 8. So the property that we're going to end up with will be, the fractional property will be, the rule will be 8 to the power, it should be b to the power of 1 over m is equals to the cube root of b to the power of n. That ends it for this property. I'll give you another property for fractional. So if you have b to the power of, say, m over n, okay, so this property you could actually think about it as fractional. And now we can apply the power of a power property. So b to the power of n divided by m, I can say that it is b to the power of 1 over n multiplied by m, power of m, and that gives me the nth root of b to the power of m. Okay, that's one way. I can also think of it as b to the power of m multiplied by the square root of 1 over n. So that would means b to the power of m, and you take the nth root of b to the power of m. So an example here could be, if I have, say, 8 to the power of 2 over 3, I can write it as the cube root of 8 and apply square to the whole term. So you're going to end up with the cube root of 8 is 2, and 2 squared you will get 4. Okay, all right, another example, for example, if you have, you can also think of it as 8 square and take the cube root of 8 square, and 8 square is actually 64, and the cube root of 64. What number cube gives you 64? The answer would be 4, and you get 4. You could see for method 1 and method 2, I find that the first method, using taking the cube root first before you square it, I think it's easier than the second method where you square it and then you take the cube root. So it all depends on the situation, and you will apply accordingly. That's it for this video.